Oh, come on.
Do it.
Okay.
Okay, so yesterday we covered 14.1 and 14.2. What we started with was with regular polygons. What we discovered, what is a regular polygon? What do we know? Well, how do we define a regular polygon?
The sides are all equal.
The sides are all equal and
The angles are all equal.
sides and angles are all
Look at the
equal. What kind of sides do I have? Are they curved? Are they straight? They are straight. So we have to make sure that they're straight sides, otherwise it's not a polygon. Okay, guys? Okay, let's put things away. Let's listen. So, what else did we also found out that something's true about every regular polygon? We can put a circle around it so it's inscribed in the circle. So regular polygons can be inscribed in a circle. So there is a point, it's basically in the center of the polygon, that's called the circumcenter. Okay, guys, please. Trying to compete with you guys, it's not fair to the rest of the class, okay? Okay, so if you have a polygon like a triangle that's equilateral, and I put the circle around it, which doesn't look very good, but there is a point in the middle, that point is called the circumcenter. Because it's the point that is the middle of the circle. It's also in the middle of the polygon. Okay, so that's really what we found out. We found out from that point, we can find central angles of the triangle, or central angles in there. The measure of the central angle is always found by taking 360 degrees and dividing it by n. Because you have, from the center, you have, depending on what kind you have, if I have a square, well, that's not a square, but anyway, you're going to have four different, the same number of radii in the center as you do sides. Okay, because you're going out to each of the points from the center. These are all the length radius, but that many as the number of sides. Here I had 3 going out to the points on the circle. So the radii, there were 3 of them, and so it broke it into 3 triangles. This breaks it into 4 triangles. It always breaks them into triangles, okay, because of that. And all those triangles are the same size in every polygon. So if this is truly a square, all of these triangles would be the same. All of these triangles inside the equilateral triangle would be the same. Okay. So we found that to find a central angle, you use 360 degrees divided by the number of sides, because the number of sides is the same as the number of radiuses that connect to the vertices, I should say. Okay. Then we found, if you want to find the perimeter, if you do not know the length of the sides, because that would be the easier way to do it. You could just multiply it by 3 or 4 or 5, okay? But if you don't know that length, but you do know the length of the radius, then you can find it using this formula, which is 2 times this quantity of n times the radius. And we define n, big capital N, as the number of sides times sine 180 degrees divided by n. Now, one thing that you could do, it's really just half the size of the central angle. If you really think about it, it's just half of the size of the central angle. Because this is 360 divided by n. This is 180 divided by n. So this number is really half of the central angle. So if you find the central angle, it's really not as hard. But you do have to remember you have to take the sine of that angle and multiply it by n. That gives you your big N, which you times by 2 and times by the radius, and that will give you the perimeter. Okay. So that's basically what we talked about in 14.1 and 14.2, using those formulas. Okay. Today, we are going to add to that in 14.3 the area of the polygon. Okay, this area is going to find out what's inside here. It will be in square units, because remember, area is always in square units. Perimeter is just a length. It's a single dimension, but area is how many little squares of a certain size that we can fit in. Centimeters, if it's a centimeter by a centimeter, or an inch by an inch, or a foot by a foot, whatever it is, whatever your dimensions are, it's always a little square of that. So area is measuring how many squares of a certain size fit in. Okay. So there is a formula that is very similar to our perimeter of the triangle, and I don't have it memorized, so I have to look it up. So the area of a regular polygon is found by this. So we are defining, still we have these numbers. We have n and r. We have those variables, okay? But we have a new letter that goes in, okay? It's the letter capital M, okay? So the area of a or of a rectangle is going to be mr squared. mr squared, okay? This is the radius, where r equals the radius, and m equals this. M is equal to the number of sides, so it's this part with some addition. N times the sine of 180 degrees divided by n, again, half the center angle, times the cosine of that same angle. This again is half the central, that is. Okay, so we've defined a new letter, M. It's really, if you find the middle angle, take half of it, okay? Because what we're doing is we're breaking them into smaller triangles that are right triangles. That's what we're actually doing, okay? Because if you think about what we are looking at, we'll try to draw. I'm not good at drawing these regular, but okay. Something like, oh yeah, that is so perfect. Okay, maybe if I draw the circle first. let's see, that would be in 1.1 point. We're gonna be right here, right here. Yeah. Okay, something like that. Looks a little better. Okay, so that is a what kind of figure?
Hexagon.
Hexagon. Okay, we're imagining all these links to be the same, so it's regular. Okay, if I take and I draw out these, notice it cuts it into triangles. Right? Doesn't matter what size of polygon you have. If you go out from the center to the edge of the circle where the vertice of the polygon is on the circle, these will be your radiuses. Okay, we can find the central angle because 360 degrees divided by n, because there's 1, 2, 3, 4, 5, 6, same amount of angles as there are sides, so we know we can get that. Okay. What we're looking for, the reason we're going to multiply this by n is because there are going to be n triangles. So we're actually going to find the triangles that you have. Okay, that's why we're going to do it by n, because the number of triangles. And then what we're going to do is we're going to find its height and its length. Okay, its height and its base. That's what we're actually looking for. That's what you get from doing the sine. So if we look at half of this angle, okay, you have the cosine is this side. Okay. And the sine is this side, and it works out just because you're looking, because we want to take the base times the height and half it. So the reason I only have to get just half of this is because my formula for a triangle, right, for area is equal to the base times the height divided by 2. So in this case, we are finding the base divided by 2 and then by the height. So cosine is actually your height. This is what you're finding here with the cosine, is the height. What you're finding, let's put it underneath. What you're finding here with the sine right here is the base divided by 2, and then you have to multiply it by n, because this is our formula for one triangle, that's the one triangle, and there are n of them, so that's why we multiply it by that, okay? Now, then we have to take the radius squared, because it's all based on this radius being your part of your sine and cosine. Yes?
Should we formula?
What? Formula. Well, similar. Okay, so let's do an example problem here. I'm going to tell you here, we have this one. We're trying to find the area of this polygon, and I'm going to tell you that the radius is equal to 5 right now. Okay? So let's go through and find first the perimeter.
Are we doing this on our own, or?
No, we're going to do it together.
Okay, let me.
Okay, I'll leave those there. We'll do them out to the side. We are going to find the perimeter of this hexagon. Okay, so the perimeter is going to be 2NR. Okay, Blake, and let's watch it here. Okay, so the perimeter is going to be 2NR. Okay, N times the sine. What is the degree of the angle? So if you look at our angle here, what's the degree of the angle that we're gonna use? Figure out what the degree of the,
55. No,
60.
that's wrong.
Wait, how many sides, or it's.
I want
It
the,
is 60.
what is the angle I'm using right here? I'm using half of the central angle.
Oh, 30.
So it would be 30. Okay, does everybody agree with that? If you look at this, there are 6 triangles. So 360 divided by 6 is 60 degrees. So each of the center angles is 60 degrees. Okay, we are using half of that. So we are going to take the sine of 30 degrees and we're going to multiply it by 6. That gives me n. Okay, so go ahead, find that in your calculator right now. What is 6 times the sine of 30 degrees?
So you were just finding the perimeter.
All
there?
we're finding, yeah,
Well, couldn't we have done it by putting
Okay.
180 or 180 over 60? That's basically what we did, right?
no, it's 180 over 6.
So 0.5 is the sine of 30, so we get 3.
Okay, so n is going to equal 3, because sine of 30 degrees is 1/2. 1/2 times 6 is 3. Okay, then it says you are going to multiply it by 2 times the radius. Okay, so you take 2 times n, which is 3, times the radius, which is 5. This is going to equal to the perimeter,
30.
which is 30. So the perimeter of this polygon is 30. Okay. And that's where we get that. Okay.
Second.
So number 2, we are going to find
1 and R, 2 and R.
the area of the hexagon.
Radius. Oh, because one of those are 5.
And it's equal to mr squared, but m is going to be 6 times the sine of 30 times the cosine of 30. So all you're adding for area is you have to add the cosine part. Notice that this is already figured out. We know it's 3. I don't have to recalculate if I don't want to, because this we already know is 3, so m is equal to 3 times the cosine of 30 degrees. So somebody figure that out. Cosine, 6
what?
times the cosine of 30. Not 6, 3 times the cosine of 30. What did
What
I
is
do? 6 times the cosine of 30 we found was 3.
Oh,
So I put 3 in there.
2.59.
Okay, so m is equal to 2.59 approximately.
Yeah.
Okay, so the area now is that number times the radius squared. So it would be 2.59 times 5 squared. So
So
25 times 2.59.
64.75.
Okay, so the perimeter is going to be equal 64.75.
Yep.
And this would be square.
Wouldn't that be the area that equals that?
Yes, thank you. That's the area. I wrote it wrong. Square units. This 30 is just units because it's just a length. If it's feet, it would be feet. If it's centimeters, it would be centimeters. If it's inches, it would be inches. Okay, so that's basically the idea in 14.3. So they're just showing you, if you know the radius of the circle that goes around your polygon, you can find out the area and the perimeter of the polygon inside of it just by knowing the radius. Okay, and so that's what they're showing you through all this. Okay, and that comes from the fact that we're finding the cosines and sines right here of that angle, because 30 degrees is this angle. When we find the cosine and sine, we're looking at r over here, and that's why then you square it by r to go from there. Okay. Okay, any questions on that? That's really what 14.3 is about. So we started with 14.1 where we defined a polygon, regular polygon. 14.2 is all about finding the perimeter of the polygon, and 14.3 is all about finding the area of the polygon. Okay. You are not required to memorize these formulas, you just need to know how to use those formulas. Okay? Yes.
Is B over 2 times H or N?
Okay, don't worry, I was just trying to show you why the area becomes that. Okay, so N is because there are that many triangles. B over 2 is the area of you're finding the area of it. But there's a little more to it because you have to find the r squared too, because we didn't use the r squared when we found these sides. Okay. Any other questions? Okay, so that's the whole thing it is, and I'm going to let you guys start working. We are not doing 14.4, so I'll take that away. You have time now to finish 13.1 through 13.4. You have time to work on 13.1, 13.1 to 13.4 if you're not. Would you stop?
What?
You can work on this,
Oh.
13.1 to 13.4,
Wait, okay, I thought we were.
or 14.1 to 14.3, and I'm putting the assignment up
Well,
right
it's gonna
now.
finish 13, so it's like, wait. That-
I agree. So what I'm hearing is I get a 25-minute nap.
No,
We get to work on 14. Since that's the way life is.
okay,
I don't think I'm gonna
you may
finish
choose to work on this if you're not finished. At the end of class, I will ask for people to turn those in.
If I finish it later today, will it count as late if I turn it in Google Classroom? Like if it won't count?
As long as it gets in today.
Okay.
Will you accept it next week?
Oh, yeah, it's still just 10%, or yeah, it's 10% off. This
It's
week
not happening today.
are these problems right here.
Let's do 14.1 guys.
So you have a lot of work to work on. There should be nobody sitting there because you have all sorts of stuff you can work on.
No. Harrison, your art
My art
is not good. I'm sorry.
It's beautiful.
I mean, I can try.
Paxton Line, Christie.
Oh no, no, not that art. No. I'm sorry, Harrison. I can't support you on that one.
What's his name? The bleak.